Hi all, we're going to start working with our clean data. So this is the exact same data that we had in the last sheet, so the raw data sheet. And now we've got it ready and set, and I've done a little bit of prep work to get us moving. But now we're going to do the forestry measurement and the forestry analysis. So we took our data in the field, and now we need to do some calculations. So we'll label this sheet calculations, calcs, and we'll start working with our data. So one of the first measurements is getting your basal area per tree. And so hopefully this is a measurement, or this is an equation that's drilled into your head. 0.05454 times your dBH squared. This gets your basal area per tree. Okay, I'm going to say it again. 0.05454 times dBH squared. That should roll off your tongue. Okay, so again, we'll use our equation function. So equals, so here's our dB, we'll put 0.005454 times dBH squared. And a great thing with Excel, we can just drag that down. So now we've just calculated our basal area per tree for every single tree that we measured. An important thing, this is your basal area per tree. This is an individual tree measurement. This is not basal area per acre. This is not something that's expanded. This is your individual measurement. This is a measurement that then leads you to be able to get to our basal area per acre and our trees per acre. So this in itself is a stepping stone. Now let's talk about basal area per acre. What is one of the great things with using a prism plot? Every single tree has the same basal area per acre. And I'm going to leave that to, we'll talk just really super briefly about that during the silviculture lecture. But those of you who are taking Chris Edgar's class, I'm going to leave that to Chris to talk more about that sampling and data. And some of that, you who have taken the August session, maybe this was one of those topics of how a prism works and what that looks like. But for this class, right? So what you need to know is that a basal area factor of 10, a basal area factor of 20, that's your basal area per acre. So we're able to just put in 10. So we use a prism with a 10 BAF, and we're able just to scroll down. So every single tree has the same basal area per acre. So that's a great thing with the prism. However, on the flip side, that means we have to calculate our trees per acre. So we need to do that math. This is different than a fixed area plot. So with a fixed area plot, every single tree has the same trees per acre. And then you calculate that basal area per acre. So to calculate trees per acre, we can use our basal area factor. So if we were in class, I would ask you, what's our basal area factor? And you would hopefully yell, 10. Okay, great, we've got that down. So 10 divided by our basal area per tree, which we just calculated. So 10, our basal area factor, divided by our basal area per tree. And we can scroll down and grab that. So now we have both our basal area per acre and our trees per acre, two measures of density. And that's really important. So we'll use those measures to summarize what we're seeing in the stand. Okay, the last one, if you notice, is diameter class. So I love a good diameter distribution. I think they provide so much information. And so with that, we got to make some diameter classes. So we're going to use our sort function, and we'll make some diameter classes. Okay, so data, sort by diameter, and we'll go smallest to largest. And there's lots of ways to make diameter classes. So they can be 1 inch, they can be 2 inches, they can start at 0.5, so it could be 12.5 to 13.4. They can be lots of different things. It's just important that you define the diameter classes. So let's go with 1 inch, since our data looks pretty much within a small range, and we'll go, so our diameter classes will go from we'll go from 0.0 to 0.9. So this one is 12.0 to 12.9. This next one looks like we've got some 13.0 to 13.9. And we're able to drag that down. 14.0 to 14.9. Wow, we've got a good amount of those in that class, don't we? So this is another kind of important part of the working with the data. While some of it is really great to be able to drag by hand, and there's other ways, some of you may know other tips and tricks and equations. Some of the things I like doing by hand, so that way I can really look at the data and see like, oh, wow, we have a lot in that 14 to 14.9 class. We've got 15.0 to 15.9. We'll drag that down. 16.0 to 16.9. Nothing in the 17-inch class, but we've got something in the 18 to 18.9. And then we jump up to 20. So 20.0 to 20.9. 23.0 to 23.9. 24.0 to 24.9. 25.0 to 25.9, and 26.0 to 26.9. Okay, so working with this data, we can either keep it like it is, or if it helps you, we can move it back to, let's do a sort. So we can put it by plot, and let's say by species. Okay. So now we have it back kind of in that order of, we've got our plot 1, 2, and 3. So now one of the biggest parts in forestry is getting averages or a per acre estimate. And some of you might be tempted to, okay, great, we'll average this. Okay, awesome. And it can be tempting to just put average in here and get a 10, our average basal area per acre is 10, and our average trees per acre is 7.6. Nope, 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 nope. Okay, so this is really where this pivot table comes in handy. And I know there's different ways. So these calculations of basal area per acre or trees per acre, Chris Edgar, I know others do this a slightly different. I think it's really important to show multiple ways to do this. So let's use our pivot table again. So we're going to select all our data. We're going to go into that insert. Clicking too fast. Okay, we're going to insert our pivot table. Oh, it's not selecting everything, so that's a great catch. So make sure you got all your data, and we should have that now, and we'll put that in our existing worksheet. Got to get that location. So that way we can see our data. So we'll put it right here. Okay. So I'm going to scroll over so we can start looking at our pivot table. So this is a great and easy way to summarize your data. So your plot, that unit of measurement, is really important. So keep that plot data there. Okay, so we've got a blank. So let me make sure we've got all the data selected. Okay, so let me make sure. Okay, so it's selected. Okay, so let's just tighten this up a little bit. Sure, it's just selecting that. Okay. Pivot table. Oh, I forgot to include the labels. Okay, so change source data. Okay, yep, make sure you get those labels, otherwise it doesn't know what it's grabbing. There we go. Okay, now it updated. We've got 1, 2, and 3. So there is our plots. So we got our plots. And we can summarize our data in various ways. So we can just start off with some of the basics. So what is our basal area per acre? And we can put that in our values. And we do want to use that sum function. So we don't want to use our average just yet. To get the total basal area per acre per plot, you have to sum up all these individual basal areas. So you have to sum every single tree. So our basal area per acre for plot 1 is 100 square feet per acre. For plot 2, 120, and plot 3, a little lower at 60. So these are totals. Again, this is not your average. This is your grand total. So let's say we want to do this with trees per acre. Okay, again, you're using that sum function. So we've got 80.3 trees, 91.9, and 41.7 trees per acre. Great, this is wonderful. Now, if we want to get averages, we can copy this and paste this right down here. And so make sure you keep your heading, basal area per acre, TPA. This is where you get your averages from. Average. And then for any average, you need some level of variation. So standard deviation. So again, using our function, average. Our average basal area per acre from the plots that we measured is 93.3. Our average TPA is 71.3. Our standard deviation is 30.5 and 26.3 respectively. So this tells you that on average there's 93.3 square feet of basal area per acre plus or minus 30.5. So you need that variability to be able to show that range. So while plot 1 and plot 2, they're pretty similar, both in terms of BA and TPA, but plot 3, that was lower density, both in terms of the BA and the TPA. So this brings up that variability. This may say, oh, maybe we need another plot or two to reduce that variability, or maybe there's some other kind of change. Again, we talked about that importance of variation within the forest. So picking up on what this means in your data is really important. Okay, so this gets at this very, very base of information. But another important component is talking about species. So we saw there's 3 different species. So what do they look like? And we'll just look at that in terms of basal area per acre. So we removed trees per acre, and we can put species over in our column. And look, we have jack pine, red pine, and white pine. And you notice, wow, jack pine's only observed in plot 1. We see red pine and white pine observed in all 3 plots. And white pine's really pretty consistent. It's a low percentage of only 20 BA per acre, but it's consistent across the 3 plots. That's pretty cool. Okay, so again, to get this information, just copy, and we'll move it down here and paste. So jack pine, red pine, white pine, total. And an important thing that pivot tables allow you to do is check. Okay, our total BA, 100, 120, and 60 matches the numbers we got there. That's a great check. These match up. Okay, so we can just kind of copy and paste this, right? Copy, paste over, and here we go. Is the average basal area per acre of jack pine from these 3 plots 20? Hopefully most of you are shaking your head, no, no, no. Yeah, no, no, no. Because jack pine was not observed in plots 2 and 3. Those are real 0 values. There was no observation of jack pine there. You need to manually add those 0 values. Those are not, so they, on average, it was 6.6, and it has a really high standard deviation because it was only observed in 1 of the 3 plots. So you need those 0 values. Okay, I'm going to repeat again. You need zero values. You have to put those zero values in to get your averages, to get those values. Okay, so we've got our 3 species, and let's say this is really interesting information. I want to highlight on average what the species look like and what the average basal area is. Great, we can now insert a figure. So if we go into our insert, and let's do a bar chart, because that's a great way to kind of highlight something like this. And so this would show, what we're showing right now is the raw values. Oops, and I'll try to move this down here a little bit without hiding stuff. Okay, this right here is the raw values. And that's interesting, that's great, but let's say that's not what we want to show. We did these calculations, so we want to show the averages. So let's just show the average. Okay, so we have jack pine, red pine, white pine, and our total. And we're gonna, actually, we don't need our total. So that way we can highlight these differences. I'm gonna get rid of some of this. Okay, so we've got this. Is your figure complete? Not by a long shot. So we need those standard deviation values. So let's go into our chart design and add some elements. So we need error bars. And you want to use that more because you calculate these error bars. So you want to specify these values. So we have our top one and we have our bottom one. And you'll notice white pine, it has no variation. Okay, and also with that high variability from jack pine, we're gonna do some formatting of our bar chart, since you can't have negative basal area. Okay, so format axis, we're gonna put our minimum at 0. So that way it's bound, because we can't have negative basal area. But we have jack pine, red pine, white pine. We're moving in a good direction. Are we done? No. So you need to make sure you have we have a label for what those units of measurements again. So we'll go into that chart design, we'll add that element, and we'll add a vertical axis. So this is our BA per acre. And we'll also make sure we let people know we did this in English units, so square feet per acre. And as you're writing this up in your report, you would then fully describe that. So we'll go through that in a little bit in the report writing, but you would fully describe this. But you just made a figure that highlights what's going on, that variability, what these species look like, and have measured your average basal area per acre. Again, your pivot tables are awesome. So we can also look at, I'm gonna do this in a different sheet because it takes up a lot more space. But we can make some figures or start looking at that diameter distribution. So we're gonna insert a new pivot table just because it takes up a lot of space. And we'll do this in a completely different sheet, new worksheet. And we can do this, we'll just start off with our plot. So we can do plot, and then we can do our diameter classes and start looking at, say, let's do trees per acre this time. We can look at how that tree per acre varies across these different diameter distributions. So you can see how species are allocating, where they're growing, how they're allocating their resources based on these different diameter classes. Again, the great thing with pivot tables is then you can add something like species on top, and you can see where different species are at with oh, white pine seems to be in those larger diameter classes compared to red pine or jack pine in that smaller diameter class. And you can make figures again regarding these and start looking at what these look like. And you can compare the different diameter classes for these three plots and see what those differences look like. I'm not going to make those figures, but that's something that can provide a lot of information. So again, another option of how you highlight your data. One final thing, we'll label this pivot table diameters, and we'll go back to our calcs. So one other interesting part is that you measured height. We don't have height for every single tree, but we can use a technique with regression to look at that. So let's kind of subset some of our data. So we'll take this into another, this is why you gotta keep a raw copy. So we'll take this into another sheet. Okay, we'll call this height by diameter. Okay, so we don't need our diameter class, so we're gonna get rid of that. But we have our heights and we have our diameters. And we're gonna sort by only the ones that have our have heights. So data sort, and we'll do by height. And using this data, we can develop a regression. And so let's say at first, we're going to use all the species. So we're going to treat red pine and white pine equally. So we can select this data, insert a scattered graph, and we can look at this relationship between height and diameter. Okay, so make sure, let's get our labels in here first. Let's get some, make sure we label stuff. So horizontal, we've got diameter. Inches. And we're gonna add height. Feet. Okay. Wow, that looks like a really nice relationship. We can add a tread line and go into those more tread line options. Oops. Hopefully y'all can see this. So, well, we don't want to, okay, so format, let's see. There we go. We've got our linear. And a nice thing we can add is we can set the equation and we can also display an R squared. So let's make that a little bit bigger for all of you to be able to see that. So and this is a really, really nice one that often doesn't happen. But look, we have an R squared of 0.76 and we have an equation. So if we wanted to, we could calculate heights. So we can do a calculated height columns here. And we can use this equation, so 1.9594, and that x is our diameter, times dBH plus 36.456. And this would give us a calculated height for the rest of the trees. So we could have an idea of, on average, what these height look like, and we can use the data we collected to provide more information on some of the things that we didn't collect, like height on every tree, because that's really, really time intensive. So there's lots and lots of ways to use this data. What I really want to get at is making sure we go over some of these basics, and also a reminder, 0, 0, zeros need to go here. Also, another piece, you have to use the sum. It is the sum. It is not. Do not use average because that will not give you anything. Okay? It is your sum. So you are summing across each of the individual plots. Okay, that's all for this one. Thanks for sticking with me, and be on the lookout for the assignment. So for the assignment with this one, you'll be working through this data set, this exact same data set. You'll be working through this raw data. There'll be a series of questions getting you through this. But the hope is that you'll be able to step through this just like I did and get comfortable. So get comfortable using pivot tables. Get comfortable with this. So thanks all, and we'll talk to you soon.